Alright, hi everyone and welcome back for lesson 3 of module 1. Today we'll be talking about solving absolute value equations and inequalities. Our essential question today is how can you find the solution of an absolute value equation or inequality? Our target will be to solve absolute value equations and inequalities using the properties of equality and inequality. So using SCAM method, which we talked about in the last video, you get the absolute value by itself. If the absolute value equals a negative number, there is no solution. And that's because absolute values represent a number's or expression's distance from zero, and distance cannot be negative. So that's why there would be no solution. To solve an absolute value equation, we do that by rewriting the two equations in their negative and positive components. Doesn't matter which one you do first, but you're basically going to negate both sides. I'm sorry, not both sides. You're going to negate the outside of the absolute value, which I'll show you in the example. Then we're going to simplify each of the two equations, solve for x or the variable. Then we're going to check our solutions. You may get a solution that does not exist. In math, we call this an extraneous solution. So whenever you come up with an equation, a solution that doesn't exist to an equation, we call this an extraneous solution. So it says here, solve, and we have 3 times the absolute value of 2x minus 3 and absolute value minus 6. So the first thing we want to do is we want to get that absolute value by itself. So I'm going to get everything to the other side. I'm going to add the 6 to both sides. That leaves me with 3 times the absolute value of 2x minus 3 equals 27. Now I have multiplication here, so I'm going to reverse multiplication by dividing. I'm going to get the absolute value of 2x minus 3 is equal to 9. Now this is where step 2 comes in. We have to rewrite our equations involving its negative and positive parts. So what you do here is, this is an important part. You take the equation without the absolute value bar, and that's the first one. Then over here you're going to replace the absolute value bar with parentheses, and you're going to put a negative sign, basically a -1 outside of that parentheses, and then equals whatever it equals. So the only difference here is you're replacing the absolute value with a parentheses and you're putting a -1 on the outside. So you're going to solve both these equations, and both these values for x typically will be solutions to the equation here, but you have to check those solutions by plugging them back in to make sure that they both exist. So let's go ahead and solve. I add 3 on both sides. I get 2x is equal to 12. Divide both sides by 2, and I get x equals 6. Now over here I have to distribute that negative, so that gives me negative 2x plus 3 is equal to 9. Now I'm going to subtract 3 on both sides. That gives me 6. Divide both sides by the -2, and I get x is equal to -3. Now we have to plug these back in to make sure that they equal 21. So let's try it. So 6, we're plugging in 6 here. So 2 times 6 is 12. 12 minus 3 is 9. The absolute value of 9 is 9. 9 times 3 is 27. 27 minus 6 is 21. So this solution works. So I plugged it in and I verified that it equals 21. Over here, do the same thing. -3 times 2, I'm plugging in -3 for x. -3 times 2 is -6. -6 minus 3 is -9. The absolute value of -9 is 9. 3 times 9 is 27. 27 minus 6 is 21. So these are both solutions. So we have 2 solutions here. Okay, we have x equals 6 and x equals -3 as solutions. Now we'll do the same thing over here. So my absolute value is already solved for, so now I'm just going to rewrite my equation 2 ways. So I write it without the absolute value bar, and then I write it replacing my absolute value bar with parentheses, put a -1 on the outside. So let's solve this one. Over here, I'm going to subtract x from both sides. I get 6 is equal to x, so that's our first solution. Over here, I'm going to distribute the negative 1. That gives me negative x minus 6 equals 2x. I add the x to both sides. That gives me negative 6 is equal to 3x. Divide both sides by 3, and that gives me x is equal to negative 2. So these are my two solutions, but we need to check and verify these solutions because they may not exist. So I'm going to plug in 6 for x. So I'll go ahead and plug in red so you can actually see it this time. So we have 6 plus 6 is equal to 2 times 6. So the absolute value of 12 is 12 is equal to 12. That's true. So this is a solution. Over here we'll do the same thing. Negative 2 plus 6 equals 2 times negative 2. Well, that gives me 4. Absolute value of 4 is 4 is equal to negative 4. Now that's not a true statement, so this is actually an extraneous solution right here. So this solution is rejected, and this is our only solution. So that's why it's so important to plug back in and check, because there are times when you're going to get an extraneous solution, and one of those solutions is not a true solution. Now we'll go ahead and look at this question. So I'm going to get the absolute value by itself. I'm going to divide both sides by the 8. This just makes it easier when we go to the next step. That leaves me with the absolute value of 5m minus 4 is equal to negative 2. Now I'm going to rewrite it in its negative and positive versions. Kind of running out of room. That's a negative 2. So I'm going to solve this one. That gives me 5m is equal to 2. So m is equal to 2/5. Over here I'm going to distribute my negative. That gives me negative 5m plus 4, because this was negative, it becomes positive. Now I'm going to subtract 4 on both sides. That leaves me with negative 5m is equal to negative 6. Divide, which gives me m is equal to 6/5. So now we need to plug both of these back in and see if these solutions are valid, if they are true solutions, or if they're extraneous. So I'm going to plug it back into my original equation. So it's 8 times 5, absolute value of 5 times 2/5 minus 4 equals negative 6. My 5's cancel. I'm left with 8 times 2 minus 4 equals negative 16. 8 times 2 minus 4 is negative 2. The absolute value of negative 2 is 2, so that's 16 is equal to negative 16. That's not true. This is an extraneous solution. So let's see if this is an extraneous solution. So I do the same thing. I plug this into the original equation. I multiply, this cancels out my 5's. I'm left with 8 times 6 minus 4 equals negative 16. So I have 2 here, so 8 times 2 is negative 16. 16 is not equal to negative 16, so there are no solutions to this absolute value equation, because it's not possible to get a negative number when you're dealing with an absolute value. So I saw this from the beginning, but I just want to show you what happens if you actually go ahead and do all the work out, because you can see here that we still end up with 2 extraneous solutions. So that's because what's equal to the absolute value is negative, and that's not possible. So solving absolute value inequalities. So you use the SCAM method, which we talked about in the previous lesson. That's basically just simplifying to get the absolute value by itself. Based on your result in step 1, apply these 4 rules. So if the absolute value of A is less than negative B, stop, there is no solution. If the absolute value of a is greater than negative b, then the solution is all real numbers, also known as the set of reals, which is denoted by this symbol here. If the absolute value of a is less than b, then negative b is less than a is less than b, and if absolute value of a is greater than b, then a is greater than b or a is less than negative b. These four rules apply to less than or equal to and greater than or equal to as well. So let's go ahead and try to solve an absolute value inequality. So first thing I'm going to do here is I'm going to get the absolute value by itself. So I'm going to subtract 3 on both sides. That leaves me with 2 times x plus 1, absolute value of, and then that's going to be negative 10. Divide both sides by 2. That gives me x plus 1 less than or equal to negative 5. So now here I'm going to do what I did before. I'm going to rewrite it as negative and positive. So negative 1 times x plus 1 less than or equal to negative 5, and then x plus 1 is less than or equal to negative 5. Now I'm going to solve. So over here I'm going to distribute my negative 1. That gives me negative x minus 1 is less than or equal to negative 5. I'm going to add 1 to both sides. That gives me negative x is less than or equal to negative 4. Divide both sides by that negative 1. Remember, when you divide both sides by a negative over an inequality, or you multiply, it's going to change the direction of the inequality. So I'm left with x is greater than 4. And then over here, I subtract 1 on both sides, and I get x is less than negative 6. So x is less than negative 6, or x is greater than 4. So let's go ahead and test this out, and it's also equal to, greater than or equal to 4. So if we look at our rules here, okay, so if you look at our rules here, we can see that we actually have a situation where the absolute value of a, once we solve the absolute value of a, the value a, which is here x plus 1, is less than or equal to negative 5. That's this first situation, which says stop, there is no solution. So we see there's no solution here, but I want to show you why this is the case. So if we take a scenario where x is greater than or equal to 4, so let's say we plug 4 in for x. That would give me the absolute value of 5. So 2 times 5 is 10. So that's 10 plus 3 is 13. 13 is not less than negative 7. So this is out. Okay? We do the same thing here, a number that's less than or equal to negative 6. So let's take negative 6 for example. Negative 6 plus 1 is negative 5. The absolute value of negative 5 is positive 5. 2 times 5 is 10. 10 plus 3 is 13. 13 is not less than negative 7. This one's out as well. So this is no solution. Now you could have done all of that without doing any of this work. However, if you forget those rules, you can still do it correctly by actually doing the math and seeing that neither of the inequalities that you come up with work. So I just wanted to show you that. Just in case you don't always remember those rules, that's another way you can go about the problem. So here, let's go ahead and isolate our absolute value so we can look and compare what rule it's going to use here. So I'm going to add 1 to both sides. I get 3 times x plus 1 is greater than negative 15. Divide by 3. I get absolute value of x plus 1 is greater than negative 5. So we have the absolute value of A is greater than a negative B. So let's see which scenario that is. The absolute value of A is greater than a negative B. That means we have all real numbers. So the solution here is all real numbers. So, like I said, if you go ahead and actually solve this out, you're going to see that this works everywhere, okay? So what you would do is you solve to get your absolute value by itself. Whatever's inside the absolute value, you're going to replace with the letter A. Whatever's over here, if it's positive, it's going to be regular B. If it's negative, it's going to be negative B. Then you compare it to this chart right here, okay? So this one says, solve and graph this inequality here. So the first thing I'm going to do is I'm going to divide both sides by the 2. That leaves me with the absolute value of x minus 3 is less than 2. So now let's think of the scenario we have here. We have absolute value of A is less than B. Absolute value of A is less than B. That means we're going to have to be doing some solving here to obtain our inequality. So to do that, we're going to write the negative and positive version of my absolute value, just like we do with the equations. I'm going to simplify. That gives me x is less than 7. I'm going to distribute. That gives me negative x plus 3 is less than 4. Subtract. Negative x is less than 1. Divide both sides by a negative. We divide both sides by a negative, we flip our inequality. So we know that x is greater than 1, but less than 7. So we can write it like this. 1 less than or equal to x, or not equal, there's an equal, less than 7. So that would be our inequality, compound inequality. So to plot this, we're going to do an open circle here. Usually you don't want to do a circle directly on the line. We're going to plot the point so you kind of just want to have a few points here. So like I'm just going to do 1, and then this would be like 3, 5, and 7. And we're going to have an open circle both here and here because we don't have an equal sign under the inequality. And that's any of the values that fall between 1 and 7 that are sufficient. So that's how you would plot this inequality. So let's go ahead and try the next one. So the first thing we always want to do is isolate our absolute value by solving for the absolute value. So we get 3 times the absolute value of x plus 2 is greater than or equal to 9. Divide both sides by 3, and we get absolute value of x plus 2 is greater than 3. So that means we have the absolute value of A is greater than or equal to B. So let's see what scenario that is. Absolute value greater than positive B. Well, we have an OR situation. So when we have those two, we have these two situations, we're going to have to be doing some solving. Is required here. If you can notice these right away, you can already say no solution or all real numbers. So I'm going to have my negative and positive versions of my inequality. And I'm going to solve. So I get x is greater than or equal to 1. Divide by a negative. When I divide by a negative, my inequality flips. So x is greater than 1, or x is less than -5. So it's going to be an or statement. So we'll literally say x is greater than 1 or x is less than or equal to -5. So to plot this, it's going to look a little bit different. So we're going to plot -5 and 1 on the number line, so you get the idea here. Running out of room. There, I just fit it in. Okay. So I have closed circles on both, and that's because of the equal sign underneath the inequality in each. And we know it's less than -5, so it's going this way, but it could be greater than 1. So these are the situation here. So it's going in opposite directions. So any of these numbers on this side will work, anything over here will work, but anything in the middle will not. In this case, everything in the middle works. So that's the difference between an and an or. So that's all I have for you today. If you have any questions, feel free to reach out to me as usual, and have a great rest of your day. Bye.